Hello friends, in this video we are going to discuss about the TLS authentication in Kubernetes. There are multiple ways of setting up authentication in Kubernetes. The TLS certificates is one way of authenticating. In this video we are going to see where exactly we need to set up or configure these TLS certificates so that the secure communication will be obtained from the clients to the server components. Let us start with API server. We know that API server is the heart of the control plane. When we want to configure our workloads in the cluster, we'll send an API request to the API server. This API request will go to the corresponding endpoint which is provided by API server, and then the API server will authenticate our request. Then the next actions will be performed. So for this authentication, we can set up the authentication with TLS certificates, which means the clients need to provide a TLS client certificate which is signed by a certification authority which is configured as client CA file in the API server. Here, the client can be the administrator of the cluster or other users of the cluster or any third-party applications which would connect to the cluster via API server. For example, as the users of the cluster, if you are executing kubectl command, we need to use corresponding client certificate. So kubectl uses that certificate to send the API request to the API server, and then API server will verify the certificate. If the certificate is valid, it will authenticate the request and it will perform the required configurations in the server based on the privileges of the user via authorization. In addition to the clients of the API server, other important components in the cluster are Kube Controller Manager, the Scheduler, Cloud Controller Manager, and so on. They also interact with the API server. So these components also should use the client certificate which is signed by the certifying authority and which is configured as client file in the API server configuration. Another important component in the control plane is etcd database server. The API server is only the component which interacts with the etcd database. So here API server will act as a client to this etcd database. So to establish the secure communication using TLS between API server and etcd, the TLS authentication needs to be enabled in etcd database, and the API server should use the client certificate which is signed by the certifying authority and which is configured as client CA file in the etcd server configuration. Now let us see how this TLS is configured in a cluster which is created by kubeadm. In a Kubernetes cluster which is created by kubeadm, the control plane components like API server, controller manager, scheduler, and etcd all are created as static pods by kubelet. So let us see these manifest files. Here we can see the manifest YAML files for all the control plane components. So let us open the API server YAML file. So here we can see the pod configuration corresponding to API server. As part of this pod, Kube API server, it will create a container with the name Kube API server. So here it has configured the TLS. So this is the TLS certificate file corresponding to API server, and this is corresponding private key file. To establish the TLS communication from clients, it uses a client CA file in this path. So this CA file needs to be used by the clients to sign their client certificates. Then only corresponding clients will be authenticated by API server. That means the users or administrators or third-party applications will use that file as a CA file. Similarly, the Kube Controller Manager, Scheduler, and Cloud Controller Manager also will use the same CA file as the signing authority to connect to the API server. Now let us open the etcd file. In the etcd configuration, it has enabled the client cert authentication is true. That means it has enabled the TLS authentication from the clients. So this is the certificate of etcd server, and this is corresponding private key. So for the clients to access this etcd server, they will use the CA file in this path. That means if API server wants to connect to etcd via TLS, it will use this CA file as the signing authority for the client certificates. So let us open API server YAML file. So here we can see to connect to the etcd server, it is using the CA file which was shown earlier. So this is the CA file which is provided from etcd server. So this CA file is used to sign the client certificate file to connect to the etcd server. Similarly, we can check the Kube scheduler YAML file as well. So here it is using a configuration file. Let us open that. So here it is using the certificate authority data. This is an encoded PEM format of the client CA certificate which is provided by the API server, and using the CA data and corresponding client certificate data, it will connect to the API server. Similarly, let us open the YAML file corresponding to controller manager. So this is also using a kubeconfig file. So let us open this file. This also contains the certificate authority data, which is the PEM encoded of the client CA file and corresponding client certificate data, which is signed by the above CA data, and this is corresponding private key. So using this client certificate data and key data and corresponding CA data, it will try to connect to the API server. So this way, the API server will connect to the HCD using TLS and also other components like clients as well as the control plane components like scheduler, Kube Controller Manager and Cloud Controller Manager will connect to the API server using TLS certificates. In addition to control plane, we also have worker nodes. In the worker node, the main component is kubelet. Kubelet will interact with API server using TLS. So this communication will be both sides. That means API server will interact with kubelet and also kubelet will interact with API server. When API server interacts with kubelet, so this will act as a client and kubelet is the server. In that case, the API server needs to use the CA file which is configured in the kubelet configuration to sign the corresponding client certificates to connect to kubelet. Similarly, if kubelet wants to connect to API server, this needs to use the CA file which is present in the API server configuration to sign corresponding client certificates. Let us see these configurations in our cluster created by kubeadm. So let us open API server YAML file again. So here we can see if API server wants to connect to kubelet, this will use the kubelet client certificate corresponding private key. Now let us open the configuration corresponding to kubelet. This is one of the worker nodes in the cluster. Here let us see the kubelet process. So this is the configuration file for kubelet. Let us open this file. Here we can see the client CA file location. So this is the file which will be used by API server to sign the client certificates which we have shown earlier. And if kubelet wants to connect to the API server, it will use the kubeconfig file. So let us open this file. So here it will use the certificate authority data, which is the same CA file content which is used by other components like scheduler and all. So this is a PEM encoded content of the client CA file which is present in API server configuration. So using this certificate authority data and corresponding client certificate and client key, kubelet will try to connect to API server. In addition to kubelet in the worker node, the pods also can interact with the API server. Generally that happens via the service accounts. We'll discuss about that communication when we discuss about service accounts. The applications which are deployed as part of pods will be exposed via services within the cluster. So we'll have multiple services in different namespaces. So we need to establish the secure communication among various services in the cluster. So generally for communication between various services, we deploy service mesh. So we'll discuss about the TLS setup between various services when we discuss about the service mesh. So if we want to expose our applications to outside of the cluster, generally we deploy the ingress controller. So this ingress controller will be used to forward the request to different services based on the context route provided by application users. So we need to implement the TLS at the ingress controller so that the application users will access our applications using corresponding TLS certificate. So we'll discuss this part when we discuss about ingress controller in the coming videos. So in this video, we have discussed about the TLS communication between various components in Kubernetes cluster. We have discussed about the API server, kubelet, the services, HCD and ingress controllers. While discussing about API server, we discussed about how the TLS is established between the clients and the API server. The clients can be the normal users, administrators or any third-party apps which can access API server via TLS. The controllers, schedulers and the control plane would also access API server via TLS. We also have seen how the worker nodes communicate with the API server via kubelet using TLS. The pods also can communicate with the API server via TLS. We will discuss this when we discuss about the service accounts. And we have seen the kubelet can be accessed by API server via TLS. And we have discussed that we can establish the TLS communication among various services. We will discuss that when we discuss about the service mesh like Envoy, Istio and so on. We also have seen how HCD database can be accessed by API server through TLS. We also discussed about ingress controllers when our applications are exposed to the outside of the cluster. So in that case also we can establish TLS at ingress controller. This would be discussed when we discuss about ingress controllers in the coming videos. In the next video, we would see how the normal users would access the cluster using TLS certificates. For that, we need to do some TLS configurations within the server as well as the client. We'll discuss that in the next video. I hope this video helps. Thanks a lot for watching.